Okay, I'm going to look at some examples using these three properties of logarithms that are discussed in the book. Basically, they're all similar, but what they kind of tell you to do, if you look on the left side of each of these three rules, it tells us that if we have a natural log of some kind of a complicated expression, we can write it in a simpler way using more logarithms. Maybe that's a nice way to say it. And for instance, this one says that if we take the natural log of two things multiplied together, we can instead take the natural log of each one and then add those together. Okay. And the other way of reading that, of course, is that if I add a natural log of two things together, if I'm adding them together, I can instead write that as natural log of the product of the numbers inside the original logarithms. Okay, so they basically the rules we can use to rewrite a logarithm or several logarithms in a different way. Here's a very similar rule using division. If you take natural log of a fraction, you can instead take natural log of the numerator minus natural log of the denominator. Okay, and this one says something about powers, and it's kind of an interesting rule. If you take natural log of something raised to a power, you can actually bring that power out as a factor. So this is natural log of x to the power n is n times natural log of x. Okay, so some of the problems that you're assigned ask you to get practice with these rules, and you'll see things like this. Here's a good example. They say expand as a sum and difference in multiples of logarithms. Okay, so they give you one logarithm of a big complicated thing, and they want you to use these three rules to really separate it. Okay, so first of all, and again, I'm going to separate every line I write with an equal sign because we're just rewriting this. Okay, the first rule I can use is this second one because I am taking natural log of a fraction, and that's the primary thing inside the parentheses. I'm dividing here, so I can write this as the natural log of the numerator minus natural log of the denominator. Okay, and that's one of the rules. Okay, but I can actually expand it further, and the next rule I can use right here is that very first one. I'm taking natural log of two things multiplied together, x and z to the fourth. So I can write that as natural log of x plus natural log of z to the fourth. Okay, and I still have this natural log of y squared sitting over here. Okay, so I've expanded it quite a bit. The only other thing I can do is that very last rule, which tells me that if I'm taking a natural log of something raised to a power, the power can be brought outside. Okay, so if I want to expand this one as much as I can still do a little bit here. I can write this as plus 4 times natural log of z. Okay, you don't need to write a dot here. And then minus 2 times natural log of y. Okay, and that's it. There really isn't anything we can do to expand this any further. One thing I will say on this example, there really isn't too much you could have done differently. In some of these you could have done a few things in a different order, but for instance, we couldn't have brought any of these powers out in the first step. Why? Because inside of this one logarithm that I started with, I don't have something raised to a power. I have a fraction. Okay. Now part of the fraction includes terms that are raised to a power, but I can't bring out the 4 right away, for example. I have to deal with the fraction first. In fact, I couldn't take out the 4 here either. I have to wait until I just have natural log of z to the fourth, and then in the next step I was able to bring that out. Okay, so these problems are just kind of to get practice using these rules of logarithms, these properties. And in fact, you'll see some problems that are kind of the exact opposite. They give you some big expression of logarithms added and subtracted together, and they ask you to combine them as a single logarithm. Okay, and that's the next example we're going to do. So again, I start with an equal sign because the directions, which you'll see, something like combine the following expression into a single logarithm. Okay, so we're just rewriting it in a different way using these rules. Okay, so an equal sign tells me I'm taking one thing and writing it successively in different ways. So, well, what rules can I use here? Pretty much the only rule I can use first is the one that deals with powers. Okay, this third rule. It says that if I have a number in front of a logarithm, I can bring it inside as a power of the expression already inside the logarithm. Okay, which is just kind of the opposite direction of how we used it before. Now the reason I have to start with that one, if you look carefully here, okay, we can't combine logs unless it's just a log minus a log. Well, that number 3 here prevents that, so I couldn't use that rule with a fraction yet because I don't have natural log of x minus natural log of something else. I've got natural log of x minus 3 times natural log of something else. So what I can do is use that third rule in 2 spots. I can use it right here with the second term. I can write this minus natural log of 5 cubed. Okay, all I did is bring the number inside as a power. Okay, and again, I might as well go ahead and use it here, right? I've got natural log of z squared. Okay, so since this logarithm is multiplied by 2, just bring in the 2 in as a power. Okay. Now, by the way, you can save yourself a little bit of time on these. 5 cubed, well, that's a number, so I might as well just compute it. That's 125, I believe. Okay, so we're still asked to combine this into one logarithm. So now I have to use the other rules, which happen to tell me what to do when I'm subtracting or adding logs. Now I need to start here because the order of operations tell us, when we have an expression to simplify, we start from left to right, doing, exponents, then multiplication and division, and then finally addition and subtraction. So I'm not going to add these two together because I have natural log of x minus natural log of 125 first. So the second rule tells us that that is the same thing as natural log of x over 125. Okay, and I've still got this natural log of z squared. Okay, so finally those two logs are being added together. You can write it as one logarithm. Again, if you look again at the very first rule, it says if you add two logarithms together, you just take natural log of the product of the expressions inside the original logarithms. So this is x over 125 times z squared, which I can write as x z squared over 125. And the directions in problems like this typically say, combine into a single logarithm. So that's good for the final answer.